In this problem, you would get into a different perspective of fluid mechanics. As you can see, I have a container containing some liquid inside it. Let's say this liquid has a density of rho. Now, there is a pipe fitted into this container and there is a hole at the end of the pipe. The problems, the theories that you have covered in fluid mechanics, that would let you understand that this fluid would flow out of this pipe with a certain velocity. You can find that velocity out. You see that depending on the height of the liquid, you can find out what is the velocity with which the fluid comes out. Okay? Let me tell you that when the fluid comes out, it also provides an opposite reaction onto the container. If the fluid is coming out in this direction, the container would receive a reaction force onto the opposite direction. Why? That you have to think about. This problem is in fact on that. So, here in this problem, instead of providing the height up to which the liquid is present, the information that has been given to you is that the rate of flow of the fluid out of the container through this pipe is equal to Q. Okay? The pipe is in this direction and the fluid is hence flowing out in this direction, and the rate of flow, that is the volume flow rate, is equal to Q. You could have been given the height of the liquid till which it is present. You can find out what is the volume flow rate from that information, but things have been made a little simpler, saying that the fluid is coming out with a volume flow rate of Q, okay, through this pipe. Now this pipe has a radius of R. That is, this cross section of the pipe is circular and the radius of this cross section is equal to R. Few more dimensions are given, that is, this height is equal to H and this length is equal to L, okay, of this pipe. What you have to do is you have to find out what is the reaction force or what is the force acting on the container, okay, as a result of this liquid coming out. It's a little tricky. You also have to find out what is the moment of that force, okay, about an axis which is passing through this edge of the container. Find that out. First of all, think what is the basis on which this force is resulted, okay? As a second part of the problem, this problem can be twisted a little bit more, okay? Let's say the container is same, the liquid inside is also same, okay? Please don't mind this bulge is not there, it's flat. The pipe is also same, but at the end, the pipe is bent a little bit in the downward direction, somewhat like this, as I have drawn in this picture. All other dimensions, information are same. That is, the density of the fluid is rho. This length of the pipe is equal to L. This length is equal to H. But the difference is that the pipe is bent at the end, which means that the fluid would now come out in this direction and the rate of flow of the fluid coming out of this pipe is equal to Q. Based on this information, once again you have to do the same thing. Find out what is the force acting on this container, okay, as a result of this fluid flow. You also find out what is the moment acting on this container as a result of this force, okay. Find out the moment about an axis which is passing through this point, okay. The axis passing through this point, somewhat like this, okay. Try these two problems out. We would be solving these two problems in the follow-up video. Think about the concept first. Thank you.